Hello, geometry students. Mrs. Myers here. So this is our fourth and final day of coordinate geometry formulas. In fact, it is also the last day of Mod 4. So after this, you are going to have a quiz to do. And then we're going to get started on our next and last module, Mod 5. So anyway, again, we are now on day 4 of coordinate geometry proofs. And this is a little bit different in the sense that it's going to start off where you are given 3 of 4 vertices. And what you need to do is you need to figure out a 4th vertice to make for a special type of quadrilateral. And then you need to justify that you have, in fact, drawn the type of quadrilateral that they told you to create. So let's get started. We got 3 problems to go through, okay? We have coordinate A, which is 1, 2. We have coordinate B, which is 8, 2. We have coordinate D, which is 3, 9. And you are to find the location of point C so that you have a parallelogram, okay? Now, notice how they named it. This is extremely important, okay, with the coming up of the vertices as the general location. So we need A, B, C, D. In that order, we need that to be a parallelogram. Now, when you name a quadrilateral, you don't just name it all willy-nilly. You name it in a specific order. So you pick a vertex, you pick a direction to go in, and you stay consistent with that direction. So if I have A, B, the next point I would go to is C, then D. So I know point C has to be in this general location. Now, here's what I am going to think about. To have a parallelogram, I need certain things to be true. And one of those things that's very, very easy to do just by visually, okay, looking at the graph, is having the opposite sides be parallel. This is not really the justification that you have to write up, but this is what I would think of to create the to find the location of this point, is opposite sides need to be parallel. So you see if you connect A to B, see how that's perfectly horizontal, okay? Well, that needs to be exactly the same for the opposite side. So we know that C has to be somewhere on the same horizontal line segment that D is on right here. Now, the other thing is where point C is has to be such that AD and BC are the same slope. So I can look at A to D, and I can see that this is a slope of 1, 2, 3, 4, 5, 6, 7 going up and 2 going to the right. So I can simply go 1, 2, 3, 4, 5, 6, 7, and to the right. And now I know exactly where point C has to be, okay? Another way that you could have done this, oh, sorry, I don't like where I have point A. Let me just fix that. All right, so another thing that you could have done, if you remember your facts, is that opposite sides of a parallelogram are both parallel and congruent. So if you had the same pair of opposite sides being parallel and congruent, that would be sufficient information as well. And since it is super, super easy to get the length of segment AB because it's a horizontal segment, I just have to count boxes. So 1, 2, 3, 4, 5, 6, 7 units long. I really could have just come here to point D. Since I know it's horizontally and 7 units across, I could have just gone 1, 2, 3, 4, 5, 6, 7, and there you go. Okay, so what is the coordinate? Okay, make sure you tell me the coordinate here. So I already know A, right, was 1, 2. Okay, B is 8, 2. D was 3, 9. So you make sure you give the coordinates, right? So you just look, it's 10, 9. So you got to make sure that you state that. Don't just plot the point and not give me the coordinates. But anyway, see, justify mathematically that the figure that you've drawn is a parallelogram. So I've got lots and lots of things that I can do, and it's up to you. I'm just going to show you one method right now, but this is not the only thing that you can do for your homework. Just refer back to day 1 notes that you can see all the different justifications for proving that you've got yourself a parallelogram. So I'm going to just do slope, and because I think slope is a very easy formula to use. Okay, it's just y2 minus y1 over x2 minus x1. Okay, and then you can just easily see, okay, that the slope of side AB, okay, is change in y over change in x, so 2 minus 2 and 8 minus 1, so it's 0 over 7, which is 0. And I'm going to compare that to the slope of side CD, Okay, and again, it's just 9 minus 9 over 10 minus 3, just for changing y over changing x. And then you can go 0 over 7 and again get 0. So now what do these equal slopes tell you? They tell you that A, B, and C, D are parallel, right? Because they have the same slopes. Okay, now I got to keep going though. So it's not enough just to have one pair of opposite sides parallel. You need to also have the other pair of opposite sides parallel. So you could do slope of side AD now. So that would be 9 minus 2 over 3 minus 1, which would be 7 over 2. And then you can compare that to the slope of side BC, which is across from it. Oops, let's put the wrong letter down there. Okay, and then that would be 9 minus 2 over 10 minus 8. And that is again 7 over 2. So I would come over here and I would say that AD is parallel to BC, because again, they have same slopes. And then what do you now know here? You know that ABCD is a parallelogram because you have both pairs of opposite sides are parallel. And that's it. That's your justification, okay? Again, that's not the only way to do it. You could have instead done the distance formula with the opposite sides and said that both pairs of opposite sides are congruent. That would have been sufficient. Or you could pick one pair of opposite sides, do the slope of them, okay? See A, B, and C, D, you can do the slopes, and then you can do the distances and say that one pair of opposite sides is parallel and congruent, so that means you have a parallelogram. Or if you like the midpoint formula the best, this is actually one of the shortest ways of proving that you have a parallelogram. Remember, you can just find the midpoints of each of the diagonals, okay? And you can see that the midpoints, if they share the exact, if they're the same midpoints, okay, if the diagonals share the same midpoints, then they bisect each other, and then you've got yourself a parallelogram, okay? So lots of different ways to do that. All right, so let's get more practice of this. This is just a general parallelogram, okay? So let's get more specific. Okay, another problem. All right, we are now going to create a rectangle. So here's our coordinates. So A is -3, -1. Okay, B is 6, 2. Okay, C is 5, 5. Okay, and you're to find point D so that it's a rectangle. So look what you've got so far. Here's A to B, here's B to C, and so you need to go C to D, so that D would connect back to A, right? See the order A, B, C, so you know D's got to be somewhere in here, right? So just think on it for a second, okay? Pause the video, right? Think on it for a second, okay? Where do you think point D is? Okay, you know the general area, but where is it? And you want to make sure, okay, that you're going to create a rectangle. So anyway, again, we know it's somewhere over here, but here's the deal. We want to get to be a rectangle. We need, and here's part of our justification, okay, is we need this to be a parallelogram that has 4 right angles in it, okay? And I think we can see that this does look like a right angle in here. But why do we know for sure it's a right angle? What kind of proof do we have, right? So if this is really a right angle, this is the idea of saying like perpendicular, is we've got a slope here. We've got a change in y, so we've got 1, 2, 3 boxes up, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes to the right, okay? So up 3, right 9, okay? That means, okay, up 3, right 9, that would be a slope of 1/3. Now, what is this slope right here? Okay, this is a slope of up 3 and left 1. So that's 3 over -1. Okay, those are negative reciprocal slopes. So we need to make sure that the next angle is also a right angle. The next one is also a right angle too, right? So it's a parallelogram, okay? And then because you have opposite side, right, with opposite sides being parallel, that would make it a parallelogram. And then because you would have your right angles everywhere, that it would make a rectangle. So anyway, you see how this was up 3, right 9, okay? Well, then that would mean to get from D to C, you would also have to go up 3, right 9. Or in other words, reverse it, and if you went left 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, okay, and then down 3, okay, see right there, okay, that slope would be exactly the same as that one. Now, is this right in here still going to be a right angle? Absolutely, because if this is the same slope as this is, and these two are negative reciprocals, then this would also be negative reciprocal slopes, right? Now, how about connecting here to here? Okay, so from A to D, is that going to be the same slope as from B to C, right? So up 3, left 1. Yep, up 3, left 1. Okay, so now let's state that coordinate. That is 1, 2, 3, 4, the left up 2, so that's negative 4, 2. Okay, so we think we've done a good job at finding that point that would make that a rectangle, but now we have to prove it. Okay, so again, first is to prove that this is a parallelogram, because remember that flow chart that I showed you on day 3's lesson, right? You have, and plus you saw it early in your school year, a rectangle is a special type of parallelogram. So prove, okay, that you've got a parallelogram first. Find the slopes of all those opposite sides and prove that they're the same. So we've got slope of side AB, okay, so that would be 2 minus negative 1 for change in y, 6 minus negative 3 for change in x, so that's 3 over 9, okay, there was that 1/3, we just did that counting boxes, okay, compare that to this opposite side here, CD, sorry, I'm writing this, slope of segment CD, and, you know, we should get that same 1/3, right? Because we counted the boxes, so we know that that's happening. But let's just prove it mathematically. See, justify mathematically. So 5 minus 2 and 5 minus negative 4. So right, y2 minus y1 over x2 minus x1. So this is, again, 3 over 9, and there's that same 1/3. So we've got the opposite sides are parallel because they have the same slopes, right? Now we go on to find the slope of side BC compared to the slope of side AD. And these two should be parallel segments as well, and they should have the same slope. Again, we knew that counting boxes, but let's just justify it mathematically. So change in y, 5 minus 2 here. Change in x, 5 minus 6. So that's 3 over negative 1. So slope of AD, same thing. Change in y, 2 minus negative 1. Change in x, negative 4 minus negative 3. And that is now 3 over negative 1. So again, same slope. So BC is parallel to AD. Okay, and then what do I know from that right there? I know that ABCD is ABCD is a parallelogram because both pairs of opposite sides are parallel. Now, something else that's really nice, what I can just do with the work here to prove that this is a rectangle, is I just need to prove that one of these angles is a right angle. So you see here the AB and the BC slope. AB and BC, I've already done those two slopes, so I'm not going to make extra work for myself here. I'm just going to come down and I'm going to like just use, oops, get a little crazy on my paper here, and I'm just going to use those slopes, and I'm going to say, well, AB I know is now perpendicular to BC, just because if I look at those slopes, right, see 1/3 negative 3 over 1, right, these are negative reciprocal slopes, right? So what do we know about line segments whenever they have negative reciprocal slopes? We know they have right angles. So now what does that tell me? It tells me that ABCD is a rectangle because a parallelogram with a right angle is a rectangle. Okay, so I didn't even need to do any extra work. I just kind of used the work that was already in my paper to make the problem as short as it could possibly be. But it's up to you. You don't have to do it that way, okay? If you just wanted to, first of all, prove that it was a parallelogram using a different method, fine. You didn't have to use slopes, right? You could, as I discussed with the previous problem, you could use a distance formula to prove that both pairs of opposite sides were congruent. You could use the midpoint formula to prove that the diagonals bisect each other, okay? So there are lots of different ways to prove that it's a parallelogram first. Or what you could have done really is you could have used all these slopes to show that every single angle was a right angle. You could just kind of have this statement every time and just be like, oh, well, as soon as you have a quadrilateral with 4 right angles, it automatically would have to be a rectangle. So that would be fine, okay? Now, the thing is, if you want to prove it's a parallelogram first and then get more specific to be a rectangle, you don't even have to have one angle being a right angle to make that work. You can have the diagonals be congruent. So if you use the distance formula for the diagonals and show that the diagonals are congruent, that would also be sufficient information to say that it's a rectangle, that ABCD would be a rectangle, because whenever you have a parallelogram with congruent diagonals, it's automatically a rectangle. All right, so there's lots of different ways to do that. So let's do one more problem for good measure, last one, okay? And now we are going to take a look at GEOM being a rhombus. So G is negative 3, 2. So let's plot that point. Okay, E is negative 2, 6. Okay, O is 2, 7. And now we need to find M, okay? So as I was saying to you before, right, think about the figure, okay, and how it's been named, okay? So G-E-O-M, right? So G-E-O-M, obviously M's got to be somewhere in here because I'm going to connect O to M and M back to G to make for a rhombus, okay? So very specifically a rhombus here now, okay? So what do I know about a rhombus? Well, I know it's a special type of parallelogram, okay? So I know that the opposite sides have to be parallel. I keep coming back to that because it's so easy to do parallelism on a graph because it's just the slopes being the same, okay? So it's easy just to count the boxes, right? But it's not just that the opposite sides have to be parallel to make a rhombus. That just makes a parallelogram. You need all 4 sides to be congruent, okay? So that's what we're going to make sure we prove here. But let's just see what the slopes do for opposite sides being parallel. So I go from G to E, and I've got up 1, up 2, up 3, up 4 to the right 1. So it's up 4 to the right 1, okay? So I know when I have this opposite side here, OM, I know I have to go up 4, right 1 for the same slope. So if I just reverse that, all right, so I am going to just go down 1, 2, 3, 4 to left 1, and I'm going to plot this point right here for M, and I'm thinking, okay, that does indeed look like that pair of opposite sides is parallel. Now also the opposite sides going from E to O and G to M, okay, those should be parallel as well. So let me just count boxes and see here. So I'm up 1, 1, 2, 3, 4 to the right, and I go from G to M, up 1, 1, 2, 3, 4 to the right. Yep, looks pretty good. So I definitely know that this is a parallelogram because the opposite sides are parallel, but is it specifically a rhombus? Okay, so are all these sides congruent? So, I mean, really, it looks like it, okay? It looks like these lengths here to here are exactly the same, but I'll justify mathematically that that's the case in just a minute, okay? But let's see what the coordinate is. It's to the right 1 and up 3, so that looks like it's the 0.13, right? So again, I just keep coming back to the same old lovely formulas of, proving that the opposite sides are parallel to have a parallelogram first. So I'm going to do the slope of side GE, and then I'm going to compare that to the slope of side MO. All right, so these opposite sides should have the same slopes, and that's just changing y over changing x. So 6 minus 2 right here, and then I go negative 2 minus negative 3. So that gives me 4 over 1. And then slope of MO, I've got change in y, 7 minus 3. Change in x, 2 minus 1. So that's 4 over 1. So yep, these are GE parallel to OM, MO, right? These are parallel segments because they have the same slopes. Now I also want to compare the slope of side EO to the slope of GM, right? Because these are opposite sides, right, that we also want to be parallel. So I go 7 minus 6 for change in y, 2 minus negative 2 for change in x. Okay, so it's 1 over 4. Now here GM, so 3 minus 2 for change in y, over 1 minus negative 3 for change in x. oops, sorry, that's a little sloppy down in there. So negative 3 minus 2 is 1, 1 minus negative 3 is 4, and these are again the same slopes. So EO is definitely parallel to GM, again, same slopes. All right, so now what do I know here? I know that GEOM is a parallelogram for sure because the opposite sides are parallel. Okay, oops, sorry, both pairs. Okay, both pairs of opposite sides are parallel. But that's not enough. I need specifically a rhombus. So I can prove really that if just any two consecutive sides are congruent, that it would mean that all four sides would be congruent. That would prove that I have myself a rhombus. So let's go to the distance formula. I haven't done that, and it's good to practice doing that today. So let's take this side GE right here. Okay, and let's find its length. So that would be change in x quantity squared plus change in y quantity squared. So I can go negative 3 minus negative 2. Okay, quantity squared, and then 2 minus 6. You can do this in any order as long as you're consistent with the work. And then that's negative 1 squared plus negative 4 squared. So 1 plus 16, so square root of 17. And I'm going to compare that to the segment OM. Sorry, EO, I mean, because I want it to be consecutive. I want it to be right after it. All right, so E to O would be negative 2 minus 2 for x2 minus x1 quantity squared. And then in the same order, it would be 6 minus 7 quantity squared. So this is negative 4 quantity squared plus negative 1 quantity squared, which is 16 and 1, and that's square root of 17 as well. So now I know that GE is congruent to EO because they have the same lengths. And then I just basically have my statement that I know that GEOM is a rhombus because, okay, a parallelogram with consecutive sides congruent is a rhombus. All right, so that would be that explanation, but that doesn't have to be the only thing that you do. You could have proven that the diagonals were perpendicular. Okay, so you could find the slopes of each diagonal, okay, down in here, and you could have shown that they were perpendicular diagonals by having negative reciprocal slopes, and then you would say GEOM is a rhombus because a parallelogram with perpendicular diagonals is a rhombus, okay? What you also could have done is proven that all four sides were congruent to each other, okay? So you would find the lengths of all four of the sides, and then just automatically that would have to be a rhombus, because anytime you have a quadrilateral with four congruent sides, that's automatically a rhombus. Now, to be more specific, to be a square, okay, and not because we know that squares have four congruent sides as well, you would have to have one of those angles being a right angle. So if this said, sketch GEOM such that it's a rhombus but not a square, then justify that, then you wouldn't just prove the four sides congruent. You have to prove that you don't have a right angle right in there, meaning that two consecutive sides aren't perpendicular. But, there's lots and lots of different options. So as long as you do some sort of necessary justification, you would get full credit. All right. So I know that this was a little bit longer to finish up day 4 of this, but it really is just a nice recap of everything. And hopefully you are feeling okay about it. And let me know if you have any questions. Remember, the next thing to come is going to be a quiz on all this this coordinate geometry stuff. Okay. So hopefully everyone is doing well, and be well.